Hey guys, welcome back to Hotshot. This is Arnav, and today we will continue our ML series. So this is the part 3. You'll find all the files in the description. Like they are ultra zipped, so they'll be of short size. And today we have made this classifier in the previous video. We'll use it to predict what we write by our hand. We'll change something here. We'll make a function and then these things. So what we need to do is open up our image editing software. I have here GNU, new image manipulation program, GIMP. So let's create a new file. It's of 28 pixels by 28 pixels, and let's decrease the resolution as well to 72 by 72 pixels per inch. 72 pixels actually. And it's a grayscale image, it's 8-bit integer image, it's a linear light. So these are optionals. You just have to do just 28 by 28 image. You can also open it up in Photoshop. Okay, so here's the image. Okay, now for this project we need NumPy. It's a free like library written for this Python. We can open the terminal and do pip install what NumPy num py. I have already installed it, so requirement already satisfied. And we can close the terminal here and let's start editing the image. So for the image, what we need to do is we need the pencil tool. The size is 3, I think. So the image is like very dark kind of. What we can do is we can decrease the hardness, I think, a bit, and the force as well. We should take the brush, I think. So we'll do it 75 hardness, 75, and force also to, let's take 85, 85. Okay, so here's the brush and it makes exact images. So now let's make an image of 1. It's the simplest image. Let's export it in our projects folder, projects, Python, tutes, ml, tut3. Oh god. It's a png file, image.png. Let's export it, and here let's import. Oh, actually we need import num numpy as np and import. You can also download this by the process I've mentioned for the NumPy. Import cv2 for opening the images. Let's define a function now, def. Let's write comments here. This functi function gives us the image in image as a numpy array. Okay, so now def image or load image. Here we take image name, image, and now what we do is I forgot the let's take underscore image. So image equals cv2 dot I am image read, and it will read the underscore image, and the image is equals to array np dot array array, we will give it image. So this will, and return image. So that's not it, but it's just for debugging. So we can comment everything out except this, and let's write the code here. So image image equals load image, and the name is image dot png. Okay, so image equals load image dot png, and then we'll print the image. Okay, let's run. So here's the image. So it is a 3-dimensional array, and instead of 0 as white, it uses 255 as white. So first of all, image have x coordinates and y coordinates, and then z coordinates for the value of each pixel. It's a 3-dimensional array, so we have to convert it to 2-dimensional array. So now what can we do is, first of all, let's do underscore image equals a list, and actually let's do it here only. For I in image, we have to do for, actually let's do for x in image, for y in z, for x in image, for y in x. Actually for y in x, what we need to do is image underscore image dot append. We have to append it to the array np dot mean of y. So that's a complex code, but image equals underscore image. Let's run the program. Now it should be a 1-dimensional array. So here it's 1-dimensional array, and now what we need to do is first we need to round, or actually I think let's round it, round. It could be a float, and then int to int, and another, yes. So now it should give us it gave us this 255. So there should be zeros in between, so here zeros also. So now what we need to do is we need to convert it back. So image equals image, but before, what we need to do is reverse the values. So dot append int and 255 minus the int of this. So let's run it again. Now we should get 000, and just the value of 1 would be 255. Okay, so now we have converted the image to 1-dimensional array. Congratulations. Now what we will do is image equals np dot array, our array of image. Okay, now we can uncomment all of this thing, and instead of test feature here, we could simply do load image 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 dot png. We could comment this out, and we can delete this. Okay, so clf dot predict sample image, everything is correct. So I think this should work. Let's run it, and importing dataset, training, and it should predict it 1. It's clearly a 1. So it displayed it as 1. Okay, and the classifier predicted it to be 1. So like, that's amazing. So now what we can do is Control Z, click Control Z here, and let's make a 2. So it's very readable 2. Let's export it. I hit Control E to export. Let's run the code again. Importing dataset, training. So you'll find this image.png and main.py and train.csv in the description. The train.csv is a large file. Oh, it displayed, and it is predicted to be 2. So it's amazing. So the train.csv is a large file, so you'll get it as a RAR inside another RAR. So it's like of 73 MB, so I'll compress it up to 7. I'll try, and that's it for today's video, guys. If it worked for you, please leave a like. If it doesn't, please comment, and I don't force people to subscribe my channel. Let's Control Z. Let's try with 3. Okay, so I hope you guys like today's video. Running, importing dataset, training, and so with this video I end my series of machine learning. That's more than enough for you. You can do anything with this. So the classifier predicted to be 3. That's amazing. You can do anything with this. The probability is endless, and let's end the video here.